Today we are discussing about the GATE 2014. GATE 2014 question, which is asked on op-amp as well as it is a combination of Zener diode. This is a voltage regulator circuit shown, and it consisting of an op-amp and BJT as well as Zener diode. And the given information is BJT has 0.7 volts of VBE and beta of 100, and Zener diode voltage is going to be given as 4.7 volts, and we require 0.9 volts output, that is output must be of 9 volts. Then what is the value of R? This is the value of R we require. Value of R over here. This is how much is going to be the value of R. It's very simple problem, okay, and the given op-amp is ideal. This is very important, and we know that one in ideal op-amp voltage gain is going to be infinite. Because of that one, there will be no difference at the input terminals, that is V plus is equal to V minus. V plus is equal to V minus is nothing but voltage across this point and voltage across this point is going to be same. So this is called as V plus and it is V minus, and difference signal is going to be 0. The meaning of this one is nothing but it is also at 4.7 volts. So negative term, that is inverting terminal, is also at 4.7 volts, which is nothing but over this point. The voltage across this point is also at 4.7 volts. 4.7 volts. So now if you know the current flowing through this resistor, at that time we can calculate the R value. R value is nothing but you can write it as 4.7 divided by current flowing through this one, that is I. So, and we also know that one no currents are going to be flows into the op-amp input terminals because of infinite input impedance. Whether the op-amp is ideal or practical, that is going to be consisting of infinite input impedance, so no currents are going to be going into the input terminals of op-amp. That is, the meaning is nothing but the current flowing through this one is going to be 0. So whenever current flowing through it is 0, at that time the same current which is flowing through this one, that is current flowing through this 1 kilo ohm, is also flow through this R. So same value of I will flow through this one. If we are calculating the value across this one, at that time that is the required value of I to calculate R value. So I is equal to, we can write here, I is equal to V naught, that is nothing but 9 minus 4.7, that is voltage difference across that resistor, divided by resistance value 1 kilo ohm, which is nothing but 4.3 milliamperes. So I value is 4.3 milliamperes. That's why we can say it as, now the R value is 4.7 divided by 4.3. So here the answer is going to be around 1.06 kilo ohms. R value is very simple. This is the answer, and only one thing is nothing but op-amp is given is ideal, that is nothing but voltage across the input terminals is same, that is V plus is equal to V minus, and no biasing currents, that is no currents flows into the input terminals of op-amp, whether it is practical or ideal. Because of that one, same voltage. Because of that one, we are assuming that one the currents flowing through this, current flowing through this one is going to be, the biasing currents are going to be 0, and here also the current flowing into this one is going to be 0. So voltage will be at the same because of ideal op-amp. So here also 4.7, here also 4.7 you will get. That is the same node, here you are going to get 4.7 volts, which is the voltage drop across this R. If you know the current flowing through this R, at that time you can calculate R value. So to know the I value, the same I is also flowing through this resistor, and we know the voltage drop across this resistor is 9 minus 4.7. So 4.3 divided by 1 kilo ohm, that is 4.3 milliamperes. So 4.7 divided by 4.3 milliamperes